Alright, ladies and gentlemen, this is Park Worksheet 1-3 rotations, Park CW1 there, or 1-3 CW1 rotations Park. We're going to walk you through a couple of these Park problems here to make your life a little bit easier. Remember, if you have any questions or concerns, just come see me during extra help. I'll be happy to help you out. Alright, so what we have here. We have triangle ABC is shown in the XY coordinate plane, as you see all around here, triangle ABC. Just in case if you can't read it, which I think you have a worksheet in front of you too, is that the triangle will be rotated 180 degrees clockwise around the point 3,4. Now just to give you an idea where the point 3,4 is, that would be 3 to the right, 4 up, aka point C. We're going to rotate around that point. To create the triangle A prime, B prime, C prime, indicate whether each of the listed features of the image will or will not be the same as the corresponding feature in the original triangle by selecting the appropriate box in the table below. So we're going to talk about the table in a little bit second, but first we want to rotate this picture 180 degrees clockwise. Now we did a couple rotations already in class, but we haven't rotated about a point that's not that 0, 0 point. And that's what we're going to do right now. So, we get this triangle, rotate it around, as you see here. We know 180 degrees, we just changes the XY to negative X, negative Y. Like we've been practicing with the rotations already. But first, before we do that, we first have to take all three of these coordinates and move it down. And we have to change the center of rotation to be in the center of our axis. So that means we got to take all these pictures. Coordinate C needs to go down 3 to the left 4. So it's the center of our rotation. We take our B. B also has to go down 4 right there and to the left 3. So that's our new B. And A has to go down 4 to the left 3. 1, 2, 3. So now once we move all three of those coordinates down 4 to the left 3, so that point of origin, or that center point which we're rotating about, is now at the origin. Then we rotate these three coordinates from xy to negative x, negative y. So 0, 0. Well, we change the signs to 0, 0, and that's still negative 0, negative 0. So my C prime is that coordinate right there in the middle. Next, we're going to take this B, or the middle stages of B, which is negative 5, positive 1, and we're going to change those signs from negative 5, negative 1 to positive 5, negative 1. Sorry, negative 5, positive 1, so it changes the sign from to positive 5, negative 1. So we're going to go positive 5, negative 1. And that's our B prime. Next, we got to take this A. This A is, well, 5, 6, 7, 8. It's 8 to the left, 2 down. So the opposite of 8 to the left is 8 to the right. And the opposite of 2 down is 2 up. So it'll be 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8, and then 2 up. I'm drawing the triangle on here just so it's a little bit easier for you to see. But on the park test, that'll make things a little bit tougher to do. Let's see visually, but you could always do things on a scrap paper. On the grids below, ones that the grids that I depict the problems that I made as a 10 by 10 grid, not just a 6 by 6. So now, once we flip-flop the x comma y to x prime y prime, or I'm sorry, x y to negative x negative y, we then have to take this same triangle and do the opposite. We went down 4 to the left 3. Now we got to take this whole triangle and then we're going to move it the opposite direction. So we got to move this C prime back. So C prime gets back up here. It goes to the right 3, up 4. B also has to do the same thing to the right 3, 1, 2, 3, and then up 4, 1, 2, 3, 4. That's the new location of B prime up there. And A, gotta go to the right 3, 1, 2, 3, and up 1, 2, 3, 4. So of course there's no grid right there, so it's a little bit tougher to see. I think you're getting the idea. We're going to practice this a couple times. And move C. Now if we see here, it's pretty close to, of course, because of the grid. My triangle might not be perfect, but we successfully rotated this triangle 180 degrees. Now, we're going to have questions below that we're going to have to answer about this picture. We'll scroll down. You can see down here is a box, a whole bunch of check boxes. So let's zoom out. And what they're saying here is to find out is the coordinate from A to A prime turn out to be the exact same coordinate? Did coordinate C and C prime turn out to be the exact same coordinate, or did it not? So we're going to take a checkbox, like a true or false. They say, will it be the same as this top row? It's going to be the same. And this bottom row will not be the same. And we're going to just click the little bubbles. So this A coordinate, my original A, which is located right over here, did my original A stay in the same spot? Oh man. So my original A, which is located there in orange, the original A stay in the same spot? No, it actually moved. A prime is all the way up there. B, which was right here, moved down to here, B prime. They're not in the same spot. But C is. C and C prime are in the exact same spot. So, A, the coordinates of A prime will be the same. That will be false. That will be not the same. So we're going to fill in that bubble. For C, the coordinates of C prime and C will be the same. That will be true. And B, there's no options for, they're not asking about B, but we know that moved too. The perimeter of ABC. Now, did the perimeter stay the same thing? You bet. It's all the same distance. It's just being rotated around. When you rotate a figure, the perimeter of the figure stays the same. So that's always going to be when you rotate figures, the perimeter will always be the same. From triangle ABC to triangle AB, A prime, B prime, C prime. Now the area of the triangle, when you rotate a triangle, the area will also stay the same. These two triangles. The only time when the perimeter or the area will change is when you dilate a figure. When we talked about dilations in class, we made the figure bigger or we made this figure smaller by a percentage. So when dilating the figure, that's when the perimeter and the area will change. The perimeter will get bigger if you make the picture bigger. The area will also get bigger if you make the picture bigger, and vice versa. If you make a picture smaller, or when you dilate a picture to make something smaller, the perimeter will become smaller. When you dilate, let's say like your eyes, when you go to the eye doctor, the pupils will get bigger. So the area of your pupils will get bigger. So the same thing goes with triangles. When you dilate a triangle to make an area bigger, or you make the triangle bigger, you're making the area of the triangle bigger. But when you rotate them, the area is going to still stay the same. Now the measure of angle B and angle B, they stay the same. because the figure is just being rotated. The slope of AC, that's a tricky one. Sometimes when with the rotations, the slope will be the same. Sometimes it will not. When we rotate a figure 180 degrees, the slope will always be the same, no matter if it's clockwise or counterclockwise. However, if you rotate a figure 270 degrees or 90 degrees, the lines tend not to have the same slope. But you always should draw the picture just to double check. But in this case, AC and A prime, C prime, they have the same slope. So I fill in that bubble. All right, next up we're going to do problem number 2. Just to see something that's a little bit easier. So we'll zoom in so it's a little bit easier to see. And we'll make sure this is nice and big for you. So here's our picture on a 10 by 10 graph of triangle ABC. As it is on the paper, I'll just read it out loud to you. It says triangle ABC is shown in the XY coordinate plane. A triangle will be rotated 180 degrees clockwise around the 0, 0 point. Now this is something that we practice a lot in class. We're rotating around the 0, 0 coordinate. So we're rotating right around that coordinate. So that means we take this figure and we rotate it. Now we're going to use that formula of x comma y to negative x comma negative y, and that's going to help us rotate our figure. Put that off to the side. So you're going to take your original coordinate of x comma y, and you're going to change it to negative x negative y. We're going to practice that right now. So we have the coordinate negative 3, negative 2. Now negative 3, negative 2, when we change that, it will turn into positive 3, positive 2. So that means positive 3 to the right and 2 up. And that becomes our B prime. Our A is negative 3, negative 7. So it becomes positive 3, 1, 2, 3, and positive 7. That's going to be our A prime. Our C is negative 7, negative 4, so it's positive 7, positive 4. And that's our C prime. Now that we have our figure, we can connect them to make it look a little bit more like a triangle. And we can see A prime, B prime, C prime. It looks like about the same size. That's because it is. When we rotate a figure, the figure still has the same size after you rotate it, no matter how many degrees of a rotation it is. Also, the perimeter is the same. The coordinate A and A prime, turns out A and A prime, as you see down here, A and A prime, they're two different coordinates, so they are not the same. B and B prime, they're not the same, they moved. They're two different locations. C and C prime, they're also in two different locations. So they will not be the same. We already talked about the perimeter and the area. Now angle measure B. Angle measure B, right here. When you rotate a figure, the angle measure is not going to change. It's going to stay the same. So those angle measures are the same. So the measure of angle B is the same. Now the slope of AB. The slope of AB you can see here is a vertical slope based on the grid that we have. When we rotate the figure 180 degrees, A prime, B prime is also a vertical slope. So when they say the slope of A prime, B prime, will it be the same as slope AB? That'll be yes. They are the same slope, so you'll bubble in that one. Alright, let's move on to the next problem. In fact, we're going to go to problem number 4. Problem number 4 is as we see here. We're going to rotate this figure 360 degrees around the origin. So once again, the origin is right there in the middle. I'll highlight that here, the big orange dot. When we rotate B 360 degrees, we land in the same spot. So B and B prime are the same. When we rotate A 360 degrees, we land in the same spot. So that's going to be A prime, right there. C, rotate 360 degrees around that circle, we land in the same spot. Turns out we have the exact same triangle, A prime, B prime, and C prime. So A and A prime, exact same point, so they will be the same. The coordinates of B and B prime, they will also be the same. The coordinates of C and C prime will also be the same. The perimeter of A, B, and C, and A prime, B prime, C prime will also be the same. And the area will be the same because we just rotated it. The angle of measure B and B prime will also be the same. And the slope of A, B will also be the same slope as A prime, B prime. So in this case, in this scenario of 360 degrees about the origin, it turns out all of these will be the same. Alright, that was a little bit of a trickier one, so I wanted to make sure I communicate that one. Alright, the next one I want to do is problem number 5, and that'll be the last one that we'll do, and then you guys will practice the rest on your own. Is that we're going to rotate this triangle 180 degrees clockwise around the point -3, -2. This is another one of those challenging ones. So to rotate around this figure, first we're going to take that B point and make it into the center, into that origin spot. I'll put a nice little orange dot. That's where we have to move that B point, or that -3, -2 point. So what I do, I move it 3 to the right, 2 up. And we can see that we have red dots in the origin. That is my B prime, or my transitional prime. Let's move our C. Our C also has to go 3 to the right, 2 up. So I'm just going to make a little mark there. And our A also has to go 3 to the right, 2 up, as we see right there. Now, once we moved all 3 points of A, B, and C, we make our little indications. We then have to rotate this 180 degrees. And we're going to use that transitional of xy to -x, -y. So 0, 0 will turn into -0, -0. So that's the location of B prime. Our A prime, we have to change the coordinates of 0 left, right, -5 down, to -0 left, right, to +5, because 2 negatives make a positive. So we plot that point up there, and that's going to be A prime. My C is -4, -2. So we got to change that to +4, +2. So +4, +2. Let me plot that point, C prime. Now that we got this triangle, we took this triangle, we moved it 3 to the right, 2 down. Well, now we have to move it in reverse. We go 3 to the left, 2 down. So we just got to move things back now. A, got to go 3 to the left, 2 down. We're just doing the reverse of that first step. 3 to the left, 2 down. And that's the location of our C prime. I'll connect them up so it looks nice and pretty. You could compare the 2 triangles. So we have ABC, triangle ABC is in orange, and the black triangle is A prime, B prime, C prime. Now let's talk about it here. Since we rotated the triangles, we know the triangles are the same size. They also have the same perimeter. Point B and B prime are the same, but A prime and C prime are not. The measure of angle B is the same by vertical angles.